Hello, I welcome you to today's lesson on my channel, my YouTube tutorials. In today's lesson, I will take you through an examinable question in chemistry. And the question says, among alkenes and alkynes, which one has a stronger and shorter carbon-hydrogen and carbon-carbon bond? To be able to determine which one of them has a stronger and shorter carbon-carbon and carbon-hydrogen bond, there are a few points that we need to know. The first point says alkanes and alkynes are hydrocarbons. Now, when we say hydrocarbons, they are compounds whose principal elements are carbon and hydrogen. So what this means is that the principal element of alkenes and alkyne is carbon and hydrogen. The second point says the carbon atom in alkane is sp3 hybridized. Hybridized orbitals are those orbitals formed when different atomic orbitals are mixed to form orbitals of equivalent energy. Now, sp3 hybridized orbital is formed when one s orbital and two p orbitals are mixed together to form sp3 hybridized orbital. The third point on the list notifies us that the carbon atom of the double bond in alkenes is sp2 hybridized. So what that means is that one s orbital and two p orbitals from the carbon atom comes together to form the sp2 hybridized orbitals. Now the fourth point also points towards that the carbon atom of the triple bond in alkenes is sp hybridized. So one s orbital and one p orbitals coming together to form hybridized orbitals. The fifth point says the higher the percentage of the s orbital in the hybridized orbital, the stronger and shorter the carbon hydrogen and the carbon bond. What this means is that if you have a higher percentage of the s orbital in the hybridized orbitals, the stronger and shorter the carbon hydrogen and the carbon bond. Now we know that the electron configuration of carbon atom is 1s2, 2s2 and 2p2. Now the orbital that is closest to the nucleus is the s orbital, and so any electron in the s orbital will have a higher attraction force, or any electron in the s orbital will experience a stronger or a higher attraction force from the nucleus. So the more it will bond to the nucleus, any electron over there will experience a stronger attraction force. So if the percentage of the s orbital in the hybridized carbon is high, then the stronger and shorter the carbon hydrogen and the carbon bond. Now with these points well clarified and I believe well understood, we'll go on and look at how to calculate the percentage of the s orbital in the hybridized orbital, sorry. So how to calculate the percentage of the s orbitals in a hybridized orbital. First, we know that alkenes, they have, or the hybridized orbitals are formed when one s orbital and three p orbitals comes together. So we are going to calculate the percentage of the s orbital in alkenes. Percentage of the s orbital in alkane equals 1/4 times 100. Now 1/4 because we have 4 orbitals or energy levels coming together to form the hybridized sp3 orbital. So we have only one s orbital out of the 4. So 1/4 times 100. And this will give us 25%. Now for alkenes, you know that one s orbital and two p orbitals comes together to form sp2 hybridized orbitals. So we are looking at percentage of s orbital in the sp2 hybridized orbital. We are having 1/3 times 100, and as I explained with the alkanes, 1/3 times 100, because we are having out of 3 orbitals or energy levels, one being an s orbital and the other two being a p orbital, and the percentage that will give us is 33.3%. The next thing is to look at how to calculate the percentage of the s orbital or the s energy level in the sp hybridized orbital of an alkyne. So we are looking at percentage of s orbital in the sp hybridized carbon being equal to 1/2 times 100, and that percentage will be equal to 50%. Now, what does all this mean? From the calculation, we have realized that alkenes and alkynes have percentage of the s orbital in them being 25%, 33%, and 50% respectively. Therefore, we can conclude that since alkenes have a 50% of their orbitals being the s, therefore alkenes have a stronger and shorter carbon-hydrogen and carbon-carbon bond than that of alkanes and alkenes. Thank you very much for watching this video, this simple tutorials to the end. And if you want to give me a thumb up, please kindly subscribe to my channel if you haven't done that already, and please like, comment and share. Thank you very much.